Multiplying complex numbers. When we multiply complex numbers, we treat I the same way we would a variable. And so we're going to multiply these two things together the same way we would two binomials. I'll use for this first example the FOIL method, starting by multiplying the first terms together, then the outer terms, then the inner terms, and then the last terms. Our definition states that the square root of -1 is equal to I. So if I square both sides of this, the squaring the square root gives me -1, and I get I squared on this side. So I'm going to make an exchange for I squared here to be -1. Combining the terms in the middle together, that's going to give me a plus I, and then the 6 just stays there. So what I have is 6 plus I plus 12. I can add the 6 and the 12 together to get 18, and then the I stays there. My final answer should look like a complex number, A plus BI, and so this answer is in the correct format. For example 2, we have a special set of complex numbers which are called conjugates. Conjugates are when the terms look identical, but one of them has a plus in the middle and the other one has a minus sign in the middle. The reason that these are helpful is when we get to the problems of division, we'll use the conjugates to get rid of that I that's in the denominator. We'll see that in the next video. I'm going to use the box method to multiply these together to kind of show what happens. We have 3 plus 4i and 3 minus 4i. What I'm doing is I'm in each box, I'm taking the two numbers that are on the outside and multiplying them together. So in this box I'll have a 9. Here I'll have a plus 12i. Here I'll have a minus 12i. And then here I get minus 16i squared. Notice that the items along the diagonal here end up zeroing out. And that's useful because what's going to end up happening is the term with I goes away completely. So what I have here is 9 minus 16i squared. I squared is the same as -1. So I end up with 9 plus 16, which is 25. Again, we use conjugates when we're trying to get rid of complex numbers because the last term changes into a real number and the two terms that have the I end up canceling each other out.